Yes, sir.
Okay. So look at this question. So they have given you standard electrode potentials. Okay. So first of all, let us look at this word standard electrode potential. Okay. So standard electrode potential. What does it represent? AKA standard standard reduction potential. Okay. So electrode potential that is standard, it is always a reduction potential. Okay, reduction potential. That is why you can see that the oxidation state of K is plus here, and here it is 0, right? That means what is happening from here to here? Reduction is happening, right, Abir?
Yes, sir.
Okay, so the first thing is that what is standard electrode potential? It is the standard reduction potential. Standard reduction potential. Okay, fine. Let me resolve the ink here, and okay. Now they have given you the standard reduction potential minus 293 for K plus, and then for Ag to Ag it is 0.80, and Hg2 plus to Hg it is 0.79, and Mg2 plus to Mg it is minus 2.37, and Cr3 positive to Cr it is minus 0.74, minus 0.74. Okay. Now see, in this case, what you have to see, if there is a minus sign here, that means for whatever reason, either it is standard electrode potential, standard oxidation potential, or standard reduction potential. Okay, any of these things is there, and there is a minus volt, there is a negative volt, that means we are giving electricity. Okay. What do you think? Is this a favorable thing? That means if I want to go from K positive to K, I will have to give minus 2.93 volt of energy, right? Yes or no? Correct?
Yes, sir.
Okay. If I want to go from Ag positive to Ag, then I will have to give. Now, this is what? This is 0. This is plus 0. That means if I go from Ag positive to Ag, then this reaction will give me this much amount of energy. Okay. So if it is positive volt, we are getting energy. Okay. We are getting energy. So positive volt is favorable, and this is not favorable. Okay. This is not favorable. Fine. Now let us look at the values and let us decide which of them. Now what is the question here? Increasing order of reducing power. Which of the following can reduce? Which of the following? It is not asking which of the following can get reduced itself. Rather, it has to reduce the others. It has to reduce others. So whenever you have been asked about the reducing power, then you will see that which can get easily. Okay. If you are reducing others, what will happen to you? You will yourself get oxidized, right? If you are reducing others, then you will yourself get oxidized. That means whenever you have to see the reducing power, you will see which of the following which can get easily oxidized. Okay, so what I will do, these are all standard reduction potential. Now what I will do, I will write the SOP for all of these things. Okay, so for K plus, to K, what I have to do, oxidation potential, then it will become K to K plus. Yeah. So this will interchange and the sign will also change, and it will become plus 2.93 volts. Okay, if I go from Ag to Ag positive, now we have flipped this reaction, hence the electrode, the potential will also change, the oxidation potential will be minus 0.80. When I go from Hg to Hg2 positive, then what I will be having, this is minus 0.79. And if I go from Mg2 positive, Mg to Mg2 positive, Mg to Mg2 positive, what I will be getting here, this is minus, so this will become plus 2.37. And if I go from Cr to Cr3 positive, then I will be having 0.74. And this all are plus. So you can see that this is favorable, and this is favorable. So first of all, you will say that K plus, that means K K has the what? K has the highest reducing power. Highest reducing power. That means it can get easily oxidized. Na? Ye easily oxidized ho gaya. What will happen? K will give you K plus plus electron, and this electron will go and reduce something. This electron will go and reduce something. Okay. Now, so the highest oxidizing power, the one which can get easily oxidized, K, followed by what?
Magnesium.
Mg, right?
Mg.
Magnesium. Followed by
Chromium.
Cr.
Cr.
Followed by
Then silver, then mercury. No, sir.
First it will be mercury, na?
First is Hg, then Ag.
And then Ag. Mercury, then silver.
Yes.
Right?
Yes, sir.
Okay. Now there is a similar question in NCERT which asks, you have to arrange the following metals in order in which they will displace each other from the solution of their salts. So you have been given these aluminium, there is copper, Fe, iron.
Sir, your
Mg.
voice is low.
My voice is low,
Yes, sir.
like very low.
Now it's fine. Like little before it was so too much low.
Okay. So you have been given now it is fine, no? Better?
Yes, sir. Now it's better.
Okay. So you have these metals and they are asking which of these metals will displace, which of this metal will displace others from solution of their salt. Okay, so first of all, see what is happening here. Which of the following will displace others from the solution of their salt? That means solution, first of all. So there will be water. Please listen carefully, don't write anything. There will be salt. Okay, there will be salt. So for example, let us see Al. Do you know any salt for Al? AlCl3. Correct?
Yes.
Yes. So what it means is that I have a salt of AlCl3. What will happen if I add copper? What will happen if I add iron? What will happen if I add Mg? What will happen if I add zinc? As you can see, there will be in this particular salt, there will be Al3 positive ions and there will be Cl negative ions, right? So as soon as I add copper, will the copper react with chlorine and it will form CuCl2? Or will the iron react with, if I put iron, will the iron react with Cl and it will form what it can form? It can form
FeCl3.
FeCl3 or FeCl2, okay, or similarly with magnesium MgCl2 or zinc, ZnCl2. Now, what reaction can happen? What reaction can happen? Now, as soon as they will, if iron is going to react with chlorine or copper is going to react with chlorine, they have to lose electrons. And whatever electrons will be lost, these electrons will go to aluminium, and aluminium has +3 charge. That means it requires 3 electrons, and aluminium will get converted into aluminium 3 plus ions. They will be converted into metal. Now you can see what has happened. In my solution, I had initially aluminium 3 plus ions. When I added some other metal, that metal came and it displaced this particular aluminium 3 plus ion and it converted it into aluminium. Now this metal rather has M, some positive charge in the solution. So this is what displacement is happening. You understand the question now? Yes or no?
Yes, sir.
Now, in this question also, what they are asking, now, which of these, if I have aluminium, for example, just we are taking the example for aluminium. If I have aluminium, then which of these following metals they can easily give electrons? If copper can easily give electrons, then what will happen? Aluminium 3 positive, it is already charged, right? So it will obviously be attracted towards electron and it will eat up those electrons to form aluminium metal. Now, what they are asking is which of the following metals they can easily give electrons? They can easily give electrons. That means if I have a metal and it is easily giving me some electrons, what is happening? Oxidation or reduction?
Reduction.
What is the oxidation state of metal here? 0, na? And what is the oxidation state here?
+1.
Oxidation ho raha hai na?
Yes, oxidation.
So it is oxidation. So they are asking which of the following can easily get oxidized. can easily get oxidized. That means again what we have to compare the oxidation potential. We have to again compare the oxidation potential, but they will not give you the oxidation potential as they have given you here. Okay, they have, and let us suppose that you don't even remember the electrochemical series. Then what you need to do? You need to analyze what are the ions. You need to analyze what are the ions. So let me just, okay. Have you written this part, Abir?
No, sir.
हाँ, इसको लिख लीजिए, ये इतना लिख लीजिए, फिर हम थोड़ा सा स्क्रीन क्लियर करेंगे.
Okay, sir.
Assalamu alaikum, Fatima. How are you?
Walaikum salam, sir. I'm good. How are you?
I'm also good. टेस्ट नहीं देना है आपको? हाँ.
Sorry, sir. I slept that day. We had model exams, right?
अच्छा, you asked a few questions about aldehyde and ketones. I remember. IUPAC nomenclature, huh?
Yeah.
Acha. So I gave some reply. Did you receive that?
Yes, I understood.
You understood, na? So you basically, the one question that was very, the one question जिसमें आपने Byju's का mention किया था, it was just the lowest locant rule that you forgot, है ना? Right?
Yes, sir.
And then there was I think it was di secondary butyl something and ketone, right?
To write the structure of secondary butyl.
Secondary butyl ketone. I think it was disecondary butyl ketone. So you have to make first ketone will be what? Ketone will be C double bond O, and will have two di. Di means there will be two of what groups? Secondary butyl group. And a secondary butyl group means what? You will have this carbon and there will be this carbon. So 1, 2, 3, 4. And there now, this is the 2-degree carbon and it has been attached with the ketone. So the 2-degree carbon, that's why this is secondary butyl. And similarly, you will have one here. That's it. But don't spend so much time in IUPAC nomenclature. Or also these disecondary butyl, this is not IUPAC nomenclature. Okay, this is common name. So generally, I will say that don't spend too much time in common names and all. Rather do the reactions and whatever entity is given there. Now, for example, they are saying benzaldehyde, then try to figure out the structure of those things, not directly IUPAC nomenclature. Abir, tell me, आपका ये हो गया?
Yes, sir.
Okay, so let me clear the screen. आज भी आप सो रही थी क्या? आप लेट आई हैं इतना? हाँ, फातिमा?
What, sir?
Were you sleeping today also?
No, sir. I attended a offline class for math, offline tuition.
So you were attending offline tuition.
So I came from there.
Acha. So these are the metals, and we are talking about which of the following metal will displace each other and will displace each other in the in the solution of their salt. So you have salt solution and there is salt, and these metals can only displace if they can easily give electrons. So if I have aluminium, then aluminium will have Al 3 positive plus electron. And if you have copper can give 2 electrons, Cu2 positive plus electron. Iron can give you Fe. You can have 3 positive and 2 positive, both, right? Yes or no?
Yes, sir.
Fe, let us say 3 positive. This will be 2 electrons and this will be 3 electrons. Then you have magnesium. Mg2 positive plus 2 electron. Will be zinc. Zinc 2 positive plus 2 electron. Now, how to determine which of the following can easily give out electrons? So first thing is that you can see magnesium, right? And magnesium is what? Magnesium is a alkaline earth metal, right? Group 2. Yes or no? Guys, tell me yes or no. What happened?
Yes, sir.
So if magnesium is going to lose 2 electrons, then it will achieve this Mg2 positive. It will achieve a noble gas configuration, right? It will achieve a noble gas configuration. Hence, we can say that this Mg2 positive is giving out 2 electrons very easily, right? So Mg2 positive will have Mg. If I put Mg in any of these, any of the solution of these particular, the salt of these metals, any solution of the salt of these metals, then Mg is going to displace them because Mg is easily giving electrons. And in this salt, you will have metal positive, for example, Al3 positive, and that electron given out from Mg, it will go on and bind with the metal, and it will form the metal ion, and it will form the metal, pure metal. So what is going to happen? Mg, whenever I put Mg, what will happen? Mg will displace that metal, and Mg will form ion, और उस जो ion पहले से था solution में, that will become a metal. Mg is going to first of all do that. Then moving further, as we can see that these are all D block elements, right? These are all D block elements, and these D block elements, even if I have removed 2 electrons or 3 electrons or 2 electrons, they are not going to achieve a noble gas configuration. The only two metal atoms can achieve noble gas configuration are aluminium and magnesium, and we have seen that, as you can see, aluminium is losing 3 electrons and magnesium is losing 2 electrons. So whenever you have to pull out electrons, there has to be some energy given, and you can see that if I have to pull 2 electrons, that will be much easier than 3 electrons. As you have seen here, magnesium I was pulling out 2 electrons from magnesium, so it was giving 2.37. But since I was just pulling 1 electron from K positive, then K positive was even higher. That was 2.93 volts of electricity was given out by K. So after magnesium, that will be obviously aluminium because it is getting a noble gas configuration. Okay, you will have aluminium. Now moving further on, look at zinc. What is the electronic configuration of zinc? Zinc is argon, 4s2, 3d10, right? Now, if I remove the electron, the 4s2 electrons will be removed, and you will get argon 3d10. As you can see, this is what? What is this? Fully filled configuration, right? Yes or no?
Yes, sir.
And this will be more stable. And after this, you will have zinc. After this, you will have zinc. Now let us compare copper and iron. So what is the electronic configuration? Sorry, atomic number of copper? This is 26. This is 27. 26 and 27. Okay. Now in this case, you have to remember. Here we are going to have Fe will be better. Okay, this is something that you have to remember according to the data, that Fe is going to be easily giving out electrons than copper. Okay, Fe is going to give electrons easily than copper. One of the funda that you can remember is if you have 27 atomic number, there will be 27 protons also. So 27 protons will be binding to the outermost electrons more effectively than the 26 protons that is present in Fe. That is why there will be easy removal of electrons from Fe than in copper. Okay, fine. So these are the two type of questions that you are going to get in terms of the metals and the reducing character and their oxidizing power. Okay, so you can write this. So Mg is going to replace all. Aluminium is going to replace zinc, iron, and copper. Zinc is going to replace iron and copper. Iron is going to replace copper. Copper is not going to replace any of them. So can I move on? Write this one. Are you done?
Yes, sir.
Okay. Now this is on representation of electrochemical cells. Okay, so here we have to depict a galvanic cell in which this reaction is happening. Zinc, and it is reacting with Ag plus ions, and what it is forming zinc 2 positive and Ag. So it takes place and further shows. You have to show which electrode is negatively charged, the carriers of current in the cell, what are those, the individual reaction at each electrode, So first of all, depict the galvanic cell. So for galvanic cell depiction, you have this A, B, and C. You have to represent this A, B, and C. A, B, and C. So what is A here? A is the anode. And what is B? B is the bridge. B is the bridge. And C is cathode. Okay. So anode. In anode, what happens? Oxidation happens in anode. What happens in anode? Oxidation. And bridge is depicted like this with two. And this is, you can say that this is a parallel type of pipe, two pipes. Okay. And what is a cathode? Cathode, in this we have reduction. Okay, so reduction happens in cathode, oxidation happens in anode. Now you can tell me zinc is getting converted to zinc positive. So what is this process? Oxidation or reduction? Tell me. What is this oxidation or reduction?
Reduction.
What is the oxidation state? भाई ये क्यों नहीं हो रहा है आपसे? Oxidation reduction में क्यों गलती कर रहे हैं आप? What is the oxidation state of? This is, I don't know, what can I say now? यहाँ पे
Reduction.
फातिमा आपको पहचानने आता है oxidation and reduction? Yes, Fatima, can you identify that the reaction is oxidation or reduction? Yes or no? Tell me. वो तो हमने बता दिया, आपसे पूछ रहे हैं आपको पहचानना आता है कि? Tell me what is this reaction, oxidation or reduction?
Oxidation.
Okay, fine. So oxidation is happening of zinc. So we'll write zinc, then a slash, and then zinc positive, zinc 2 positive, followed by a bridge. And reduction is happening for Ag, right? So we'll write just Ag here. Okay. So what is reduction? Ag positive is getting converted to Ag. So as you can see, this is oxidation and this is reduction. So that should also be depicted. And there are furthermore what you can add some details also. You can add some details. For example, you can see that zinc 2 positive is going to be, you can add the phases also. Phases means what is the state of these particular atoms. So zinc, you can add solid, gets converted into zinc 2 positive, and it gets an aqueous phase. You can write Ag positive, which is in aqueous phase, gets converted into Ag solid, gets converted into Ag solids. Okay. Now here you can see that. Here you can see, here we are having oxidation, here we are having reduction. Now the question is which of the electrode is negatively charged? So which of the, this is anode, so you will have to tell me which is negatively charged, anode or cathode?
Anode.
Anode is negatively charged. Why? Why it is negatively charged? क्या हो गया? Because of the reaction. Okay, because of the reaction, here we are having zinc, right? Zinc, it is getting converted into zinc 2 positive plus 2 electrons. Now these electrons are what? These electrons are putting up the negative charge in this anode part. Okay, so anode here, please remember, it is not, you cannot generalize that anode will always be negative. Anode is where oxidation happens. Okay, so anode is where oxidation happens, and in this case, when you look at the reaction, what is happening in this reaction? Zinc is giving me 2 electrons, and that's why it is getting a negatively charged. It is getting negatively charged, so this will be negatively charged. Okay, so this is anode. The answer here is anode. So what are the carriers of the current in the cell, right? So in the cell we have 2 carriers. So we have the wire in which the electron flows, right? The wires in which the electron flows, and then we have these 2 containers between which we have salt bridge. And inside salt bridge, what is there? And as soon as this get dipped here, and inside the container there are ions. So here we have ions, and in the wire we have electrons. There are 2 carriers. There are ions and electrons. So if we don't have ions, then also the cell will stop working. And if you don't have electrons, then obviously the cell is going to stop working. And you have to write the individual reaction at each of the electrode. So for at anode, you can write zinc is getting converted to zinc 2 positive plus 2 electron. And at cathode, what is happening? At cathode, you are having Ag positive plus electron getting converted to Ag solid. Okay, Ag solid. Then furthermore, what you can have, you can be asked to write the complete cell reaction. So you have to, so this is the complete cell reaction. Okay, so this is the complete cell reaction that is given already here. Okay, Chali. Can I move on?
So
Sir,
what
the
will be the
carrier.
answer?
Huh? What should we write, or what you're asking?
What
Huh?
will be the answer of second one? The carriers of the current in the cell.
Ions and electrons, no? See, I have written ions and electron.
Okay. Sir.
Okay. So individual reaction is this anode and cathode. Can I move on? Yes or no? Tell me.
Yes, sir.
Okay. Now, there is standard cell potentials. Standard cell potential of the following reactions. Okay. So standard cell potential. So there will be some formula in your book, but I will ask you to remember only one thing. So the standard electron potential that is written as E naught of cell, this will be E naught of oxidation plus, please remember, E naught of reduction, but this E naught of oxidation will be of the entity which is getting oxidized. Okay. So species getting oxidized. Okay, so E naught oxidation of the species that is getting oxidized, and E naught reduction of what? E naught reduction of also the species getting reduced. So first of all, what we have to find, which of the following is getting oxidized and which of the following is getting reduced. So which will get oxidized? The one that easily gets oxidized. जो easily हो जाएगा, the one which gets easily oxidized will be oxidized, and the one which gets easily reduced will be reduced. That means if I want to get something easily oxidized, its standard oxidation potential should be high, and if I want something to get reduced, its standard reduction potential should be high. Okay, everything is in line? Yes or no? Please tell me.
Yes, sir.
So E naught cell will be E naught oxidation of the species getting oxidized, reduction will be species getting reduced, and now we will ask what is getting oxidized. So the one whose SOP is higher, and what is getting reduced? The one whose SRP is higher. Now please remember, SRP has another name which is known as standard electrode potential. Standard electrode potential is the standard reduction potential according to the IUPAC norm. Okay, according to the IUPAC norm. Now, here we have SOP. And what is the relationship between SOP and SRP? Now, not between these two, but the SOP of a particular entity. Okay, now let us look at calculate the standard cell potential for the galvanic cell in the following, in which the following reactions take place. Now, in this first reaction, in this first cell, so what is the oxidation happening? Whose oxidation is happening? Tell me. Chromium, right?
Yes, chromium.
Chromium. Okay, so first one, oxidation is happening for chromium, and reduction is happening for cadmium, right? Yes or no?
Yes.
Yes, sir.
What you will do, you will write like this: E naught oxidation of chromium. That means Cr is going from Cr to Cr3 positive. Cr to Cr3 positive. Now tell me, is this value given?
No, sir.
What is given? The opposite is given, na?
Yes.
So what we will do, when we have flipped these entities, then the sign will also get flipped, and this will be equal to plus 0.74. Clear?
Yeah.
Okay, so we have been given the reduction potential, we are calculating the oxidation potential. So reduction and oxidation, these are opposites of each other. That's why you will get a positive sign here. Moving further on, we have E naught. So we are going from cadmium to positive to cadmium. And is this given?
Yes, minus 0.40.
0.40 volts. Okay. Now what we have to do, we just need to add it. Hannah? What we need to do? We just need to add it, right? Tell me what will be the answer if you add them. There will be 4 here.
Plus 0.34.
Plus 0.34. As you can see, we are getting electricity. Now, whenever you have plus voltage, that means we are getting electricity. Whenever there is minus voltage, that means we are getting, we have to give electricity. Okay, so the first one is done. सेकंड वन आप खुद से करके बताइए। Correct, Fatima. Waiting for your answer, Abhi. Abhi, can you identify whose oxidation is happening and whose reduction is happening?
Yes, sir.
Tell me whose oxidation is happening.
Iron.
कीजिए
Fe.
जल्दी कर, हाँ जल्दी कैलकुलेट कीजिए बट, है ना। Correct. Moving further on, so this question has one more part, and that part is regarding the delta G and the K. Okay, so calculate the delta G naught and equilibrium constant of the reactions, the above reactions only. Okay, the ones which you have calculated. So here we have delta G naught. So how to calculate delta G naught? So the formula is delta G naught. It is equal to, if you have got the E naught of the cell, then it will be equal to minus N F E naught of cell. So you know what is E naught of cell? Obviously that you have calculated. What is N? The number of electrons involved in reaction. Number of electrons involved in reaction. What is F? F is the Faraday's constant, right? F is the Faraday's constant, and its value is approximately equal to how much? 96500. 96500. And what are its units? Coulomb per mole. So here they are talking first of all number of electrons. Number of electrons. So if you look at the first reaction here we have 2 Cr and here we have 3 cadmium, 2 positive, and there are 2 Cr, 3 positive and 3 cadmium. So what do you think? What is the number of electron that is getting transferred in this reaction? बताइए इसमें से कैसे देखना? If you want to so there is a specific trick. If you have this type of reaction in which you have one neutral, one positive, one neutral, है ना? In both of the sides, what you have one positive charged species and the other is neutral. But in the second equation, you can see that both of these are positive charge, and in the other case, we have only one positive charge. Okay, so if you have this type of reactions in which there is one positive, one neutral, one positive, one neutral, then what you need to do? You need to multiply the stoichiometry of any one of them, on any one of the charge species, stoichiometry into the charge. Okay, so what is the stoichiometry of any of the charge species? Look at this species or this species, है ना? So if you look at the stoichiometry of cadmium, it is what? 3, and the charge is 2. So the number of electron will be equal to 6. And here also, if you took chromium, then also the stoichiometry is 2, but the charge is 0.3. So you will again get 6. Okay. But if you see what is happening, essentially, let us look at one of these reactions. Okay, so you are having 2 Cr. It is giving me 2 Cr, 3 positive. That means from each Cr we are getting 3 electrons, right? And since we have 2 Cr, that means we are getting 6 electrons. Okay, so this is how you calculate from the reaction. But if you have this type of equation, that is very general equation, and most common equation is you have one positive, one neutral, then you can just do the stoichiometry into charge and you will get the number of electrons. Now, but if you have this, then you have to look at the reaction. You will have to look at the reaction. There is no other choice for you guys. So Fe2 positive, and it is getting converted into Fe3 positive. So tell me, how many electrons are getting out from Fe? Only one electron, right? Yes or no? That is why they are having an increase of one charge, right? 1 unit charge. From 2 positive, it is getting 3 positive, because if I remove one electron, there will be an increase in 1 unit charge, right? Yes or no? Yes, Fatima, Abir, what happened? Nahi samajh mein aaya ye?
Yeah.
Got it now? What about Abir?
Yes, sir.
Okay. So for this case, question number 1, n will be equal to, question number 1, n will be equal to how much? 6 into Faraday's
Sir,
constant
the
will be
minus.
minus
What is the minus for?
minus.
What does the minus stand for? Like it is the equation.
In the equation here.
Yeah.
Okay, fine. So we know that when we are going to talk about E0 cell, when it is positive, there can be two cases, and it can be negative, right? So when it is positive, it is what? It is giving giving electricity. Sahi hai? And if it is negative, then it is taking electricity. The cell is taking some electricity from us, right? Itna clear hai?
Yes.
Fatima? Okay.
Yes,
Now you tell me
sir.
which of the following is spontaneous. Giving is spontaneous hai, ya fir taking spontaneous hai? Which of the reaction will happen automatically? The positive one, na, in which the electricity is given out, because we are not doing, or we are not giving any other energy to make that reaction happen. That means whatever reaction is happening and it has a positive E0 cell, that is a spontaneous reaction, correct?
Yes.
सही है ना? अच्छा, अब delta G जब होता है, now what is the delta G? Delta G also can have positive values and it can have negative values, right?
Yes.
And if you remember 11th class, this positive value, it signifies non-spontaneous reactions, and negative values, it signifies spontaneous reactions.
Okay.
याद आया? नहीं याद?
Yeah.
Okay. Got it now? Okay. अब यहाँ पे आपको दिख रहा है कि like if we have E0 cell, then the positive is spontaneous and the delta G0 में क्या है? Negative spontaneous है. That is why you have to put this sign in order to make this things work. Got it now?
Okay, sir. Yes, sir.
है ना? Okay. Fine. So here we have minus 6 into the Faraday's constant will be what? 965 00 coulombs per mole, multiplied by E0 cell, what we have got here, 0.34. Now, actually, the number of electrons will be 6 moles, because whenever we write reactions, they are in terms of moles. This mole and mole will cancel out each other. And what will happen? Here, after that, you will get all of this now. So now this delta G0, it will be coming up in the terms of energy. So we'll have coulomb, and here you will be having what? Coulomb and volts, right? Yes or no? Coulombs and volts. So this will convert coulomb into volt. If you have some physics, then it will be, this is equal to joules. Joules or kilo? No, coulomb into voltage is equal to joule only. Is equal to joule. So whatever you multiply, this will come in terms of joules. Okay, this will come in terms of joules. Okay, so you can multiply these things, right? So this is the equation if you have delta G0. If you want to calculate the delta G0, once you have calculated the delta G0, then this equation from thermodynamics, will be used for the calculation of the equilibrium constant for these reactions. Equilibrium constant. This is equal to delta G0. It is equal to what? Does anyone remember the reaction? Sorry, the formula, minus 2.303 RT log Kc. Okay, so this is the equation. Now nothing of this equation is from electrochemistry. Delta G0 is from thermo of class 11th. Equilibrium constant is from chapter equilibrium from class 11th. Okay, but you are getting this delta G0 from what? Electrochemistry. That is minus NF E naught cell minus NF E naught cell. Now can you see, and you can see the link between everything. We can have a device or an instrument that can measure the electricity E naught cell, right? Hana? Yes or no? Tell me. Sorry. Voltage ना आपने का machine नहीं देखा, आपने voltmeter देखा ना? नहीं देखा, like you have heard ना, there is a voltmeter, right? Fatima, Abir, नहीं.
Yes, sir.
Yes.
So you can have an instrument. You can have an instrument that is going to measure E naught cell. From there, you are going to calculate the delta G naught, and you just need the number of electrons that you can have by written equation. You will have written equation, and from that you can see how many electrons are there. And after you have calculated the delta G naught, what you can do, you can plug it in here, and then what you are going to get, you are going to get a Kc. You are going to get the Kc, that is equilibrium constant. And this is a purely theoretical thing. Purely theoretical thing. You cannot directly measure it. So you can start it with a measurement and you ended up with something that is theoretical. So write these two equations. You just need to plug in the value of delta G naught, and then you have, okay, fine. So when you do all the calculation, you will be ending up with log Kc is equal to something. Some value here. Let us say X. Now please remember, if you want to calculate X, so log it has a base of 10. 10 to the power X will be equal to Kc. 10 to the power X will be equal to Kc. Right, so Kc will be equal to what? 10 to the power of X, whatever it is. Now, if you remember, I have shared with you guys some a small 6-page booklet on log and anti-log. Please refer to that. ये आप लोग कर दिए खुद से anti-log कैसे लेते हैं of any value. But if you don't know how to take anti-log कभी-कभी दिया भी रहता है यहाँ पे. The anti-log of this much is that value, so you can use that, or else you will just leave the answer till here. Log Kc is equal to X. Okay, अगर नहीं आ रहा आपको anti-log, so don't waste too much time on anti-log. Okay, step marks मिलेंगे आपको अगर इस तरह का सवाल रहेगा तो. And some, if you have a good handwriting, now again, this whole world is biased. If you have a good handwriting, पता नहीं आपको log Kc में भी full marks मिल जाए, ठीक है? So if you have done everything very neatly, but at the end you have just written log Kc is equal to X, then also teacher will be like, अच्छा ठीक है, सब आता है, बस anti-log नहीं निकालना. Okay, given marks. Chemistry आता है, maths नहीं आता, ठीक है, कोई बात नहीं. Okay. Now can I move further on? जल्दी बताइए.
Yes, sir.
Okay. Now moving on. Here we have what I can say the heart of this whole chapter is Nernst equation. Okay. Nernst equation, and Nernst equation comes under the topic which is the effect of concentration. Effect of concentration on E naught cell. Okay, not E naught, sorry, on the E cell. E naught the standard hota hai, it will not be changed on the E cell. Now, how can we change the concentration and get maximum out of a particular cell? Okay, we can get a maximum out of a particular cell. Now, one thing is very important that you have to remember. Please note this point. Nernst equation is not written for a electrochemical cell. Okay. So the Nernst equation is never written for an electrochemical cell. This will seem a bit ironic and something very opposite, but please remember, a Nernst equation is never written for an electrochemical cell. आपको electrochemical cell दिया, आप कभी भी Nernst equation से नहीं लिखेंगे. Okay. First, what you will have to do, whenever you have been given a cell, you will convert that cell into a particular reaction. Please write the next line. Nernst equation is only written for a cell reaction. For a cell reaction, this is very important, because both of these things, they may be interlinked with each other. You can get an electrochemical cell from the cell reaction. You can get a cell reaction from an electrochemical cell. But please remember, a Nernst equation can only be written for a cell reaction, not a electrochemical cell. The important point, I will tell you why. Let us look at the first question. Let us look at the first question and let us see at anode what is happening. At anode, what is happening? At anode, what we are getting Mg, which is getting converted into Mg to positive. Is that right? Yes or no?
Yes,
So yeah, plus 2 electron. Now, what is happening at cathode? अच्छा ये वेट इन कैथोड यहाँ पे तो आपका चल जाएगा काम. अच्छा in cathode what is happening? Cathode we are having copper 2 plus 2 electron giving me copper solid. Okay. Now the cell reaction, you will add these two reactions. So this 2 electron and 2 electron will be getting cancelled, and you will have Mg plus Cu2 positive is giving me Mg2 positive plus copper. Is that fine? Yes or no? Please tell me till here.
Yes, sir.
Okay. Now you can write the Nernst equation. So Nernst equation is what? E cell. Okay. कुछ याद करके आए आपको? कुछ याद है? Nernst equation क्या है? E cell is equal to E naught cell minus नहीं याद है minus 0.0591 divided by n. N is the number of electrons that is getting used in this particular cell reaction. Okay, number of electrons log of product upon reactant. But please remember the concentration of product upon reactant, in which you will just be writing the ions and not the solid, because solid's concentration it doesn't change. Solid's concentration it doesn't change. Why? Because look at here. Concentration is what? Concentration is number of moles divided by volume. Now what happens if I react a particular solid? This solid will be reacted and there will be a solid left like this. So now what has happened? There are two things which has been decreased. Number of moles has also been decreased. The volume has also been decreased. And if the number of moles and volume both are going to decrease, then the concentration is going to be same only, right? Numerator and denominator, both of them are decreasing. That means this whole quantity, the ratio will be same, right? नहीं. अबीर फातिमा क्या नहीं सुनाई नहीं दे रहा है आप लोगों को? क्या लिखने में बिजी हैं आप लोग? Yes, Abir and Fatima. Abir and Fatima.
Yes, sir.
Yes. Did you understand why solid? We don't write solid in products concentration or reactant concentration, because their concentration does not change.
Yes, sir.
Okay. Fine. So what is the product here? Mg2 positive is the product, right? Mg2 positive divided by copper 2 positive. Okay. So in this Nernst equation, you just need to calculate this n. Can you tell me what will be the n? 2, right? Can all of you see 2? Yes or no?
So what?
N. Number of electrons in this
2.
reaction. 2, na? Okay, I am pushing. Okay. So now you can substitute the values also. You can calculate the E naught cell. E naught cell कैसे calculate करेंगे? E naught cell will be equal to again what? Oxidation and reduction. ये देखिए पहले जो हम लोगों ने किया ना, calculate the standard cell potential. The same thing is getting used here. So in this one question, you have to calculate the E naught cell also. So how will you calculate the E naught cell? So anode we have oxidation. So Mg2 plus, what we will do? We will convert this. So this will be becoming plus 2.37, and you will have copper 2 plus. Where is copper 2 plus? And plus 2.37 plus 0.34. You will add these two values, right? Yes or no?
Yes, sir.
Yes.
And whatever you are getting, you will write that in E naught cell. You will write 2 here, and then you will plug in the value of this concentration of Mg, and this is the concentration of copper, and then you can calculate. Now everything is just you can say, okay, let me calculate this one. 7 and we have 3 4 7 plus 4, it will be 11, and okay, 2.71 will be the E naught cell minus 0.059 divided by 2. Now you can 0.599, so 0.06 भी कर सकते हैं आप. Log of Mg2 plus concentration is 0. So this is 10 to the power minus of 3, and this is 10 to the power of minus 4. So this will become log of 10, I think, right? 4 ऊपर चल जाएगा, that will be positive. And yeah, so log 10. So log 10 is equal to 1. So you will just ended up with 2.71 minus 0.06 divided by 2. And so after that, it becomes easy. You can calculate this value. So 2.71 minus 0.03. है ना? कितना हो जाएगा? 71 में से 3 निकाल देना. 2.68, right?
8.
68 है ना? Okay. Now I will also do, see, in all of these questions, you can see that the first question is about concentration. And if you look at the other question, they have concentration and they have pressure. Here, this is an important question. Here you have got this type of equation in which you have, this is concentration, then there is bridge, there is again concentration, there is again a pressure. Okay. And here also you can see, here you have PT and Br negative and you have 0.0 M. Then again you have Br2. So you have three things happening here. And here again you have H plus, then H2 on bar, and then again there is a platinum electron. Okay. So tell me which of the following should I do here? The third or the fourth? I'll do one of them. The difference between these two is that Sn is an active electrode. That means it is also taking part in the, this is also taking part in the reaction, and platinum is an inert electron. It is not taking part in the reaction. Okay. So this platinum is not taking part inside the reaction. Third one.
Yeah.
Okay, fine.
The fourth one.
अरे ये भाई ऐसे थोड़ी ना होता है. थर्ड और फोर्थ, एक थर्ड बोल रहे हैं, एक फोर्थ बोल रहे हैं. फोर्थ कर ले.
The third is like first one is easy, right? Sn to Sn2 plus is same like this one.
अच्छा अच्छा, you can easily see the reaction what is happening. यहाँ पे भी तो आपको दिख रहा होगा. अरे ये देखिए ना, Br नेगेटिव से Br2 भी तो हो रहा है.
Sir, but platinum solid is there.
Platinum solid is there. अच्छा, you are okay. Platinum solid is there.
Three is there.
अच्छा, ठीक ठीक. Okay. Okay, fine. So Fatima, ये जो है ना, like in, अच्छा, can you see Fatima? It's okay ना? You understand that? Okay. So the cathode part is same only in both of these cases, है ना? And you can relate the anode part with the first reaction also. First question also, correct?
Yeah.
है ना? Okay, fine. So let us do the fourth one. Let us do the fourth one. So in the fourth one, we, अच्छा, ये fourth one का हमको ये लिखना पड़ेगा. So this is platinum, then Br. अच्छा, can I erase this part? Whatever is written here.
Yes, sir.
है ना? Okay. Fine. Now again, we need to look what is happening here. So here we have Br negative and Br2. Here we have H positive and H2. ठीक है, इतना ही देखना आपको. You don't have to look at platinum. Why? Platinum, it is inert. ठीक है, inert means what? It is not taking part in the reaction. Okay, so it doesn't take part in the reaction. Okay, so you have to ignore. Why? But why have they given you the platinum? Because they are showing you the electrochemical shell. They are not showing you the electrochemical reaction. So जहाँ cell की बात आती है, they have to show what are the electrodes that they are using. But we are more interested in the reaction that is happening. Okay, the reaction that is happening. So this is how the cell is constructed. You have platinum electrode in the anode and platinum anode in the platinum electrode in the cathode also. So let us look at the reaction. What is happening? So what is the reaction here? Br negative. It is getting converted to Br2, right? So this is happening at anode, right? Yes or no?
Yes, sir.
Tell me. First of all, we will balance this whole thing now. So this will be 2Br. Sahi hai?
Yes, sir.
Okay, let me get a bit more space here. Now Br, it is Br negative is getting converted to Br2. Hence I have written 2Br negative. Why? Because they are a 2. Now let us talk about the charge. So what do you think? How many? What is going to happen? This is going to give electron, or it is going to eat electrons? Yeah, tell me. Br negative. If I want to convert to Br2, it is going to eat electron, or it is going to give electrons? अच्छा, यहाँ देखिए. Abhi, you don't know the answer to this?
No, sir.
No. Fatima, you don't know the answer to this?
No.
No. Okay, fine. Let us see. Look at the charge. What is the charge at Br? This Br negative, it has a negative charge, right?
Yes, sir.
And this Br2 is neutral. Correct? Yes or no? Yes,
Yes.
Abir and Fatima. Okay, now you tell me, if I have to go from negative to neutral, should I remove negative or add negative? Tell me.
Remove negative.
If I have to remove negative, then what is the charge on electron, positive or negative? What is the charge on electron? Electron, positive or negative? Abir? Abir.
So if we remove the electron, then the
नहीं, हम क्या? No.
charge.
Wait. What I'm asking? What is the charge on electron?
Negative.
Positive or negative? Negative charge. बस वही बताते हैं ना. If I have to remove negative thing, then what do you think I have to do with electrons? This Br has electrons, no? So should I remove electron? Right? We should remove electrons, right?
Yes, sir.
So if I will remove electron, I will get electrons here. So if I remove one electron from each Br, I will be removing this Br negative. You remove this negative charge. So you have removed one negative charge. That means you have removed one electron. With 2 Br, you are removing 2 electrons. So in Maya?
Yes, sir.
Yes.
Okay. Like, I hope you can see now how to look at the reactions and tell whether it is going to eat electrons or give electrons. Fair. Moving on to here. So here what is happening? H positive to H2. Here we have cathode. And here we have H positive. And it is getting converted to H2. So here we have positive charge. So in order to make it neutral, I will have to add, again, here there will be 2 H positive, and you will have to add 2 electrons here, right? So I have 2 positive charge and 2 electrons. That's why it is going to give me neutral. If I write the cell reaction here, it will be this 2 electron and 2 electron will be getting cancelled, and you will be having 2 Br negative plus 2 H positive. It is going to give me Br2 plus H2. Is that fine? Yes or no? Tell me.
Yes, sir.
Okay, this is Br2 is liquid and this H2 is gas. Okay, this H2 is gas. We have to see this. We are going to put this H2 in the Nernst equation. Okay, so if I write the Nernst equation for this, what will be the Nernst equation? E cell. You will calculate the E naught cell. And E naught cell आपको लोगों को दिया हुआ रहेगा, ये देखिए. Okay, and for H2 it is for hydrogen it is 0 only. Okay, because it is standard hydrogen electrode. It has the 0 E naught cell. Standard electrode potential for a standard hydrogen electrode, it is 0. E naught cell minus 0.059 by how many electrons are used? Tell me. How many electrons are used? जल्दी बताइए. अरे लिखा हुआ चीज आप लोग जल्दी क्यों नहीं बताते? You take so much of time. 2 log of the product. So in product we have only one thing which we can write, that is H2 gas, right? We can write the pressure of H2 gas, because again, if I have liquid also, if a liquid is being reacted, then what is going to happen? The liquid, its volume will also be getting reduced, but in gas it can have a lot of volume there. Okay, so pressure of gas is taken in the Nernst equation. Okay, so this is pressure of H2 we will take and divide by Br negative concentration raised to their stoichiometric coefficient. So we have Br raised to the power of 2 divided, and also H plus raised to the power of 2. Now you can plug in the values, calculate the E naught cell, and this will be again 0.03, and then you will calculate.
What is that before H2?
P.
On the numerator. P.
Pressure. And so ऐसे लिखते हैं, या तो उसको pressure of H2 like this you write, or you write it like this. Pressure of H2. Oops, sorry, H2 यहाँ पे ऐसे होगा. Better way is to write it like this. It is pressure of H2. Now, one more thing that I want all of you to do whenever you are writing this type of question. So the E cell that you will be calculating, it can be either positive or it can be either negative. Okay, so when it is positive, you will say that since the E cell is positive, this cell reaction will take place spontaneously. Okay. Now, if the E cell is whatever you are calculating, it is negative, then what you are going to say, since it is negative, this reaction will not take place. This reaction will not take place. Okay, and if it is positive, then that reaction is going to take place spontaneously. Done? Can I move? Yes or no? Tell me.
Yes.
Sir,
हाँ बताइए बताइए.
for this reaction, E naught cell is 1 plus 1.08, right?
E naught cell.
Yes.
Okay, so we have अच्छा.
So for H plus 2, H it is 0. Okay.
फिर आगे.
So this much only.
हाँ.
So this was the question, my question. Like,
Your question was something else. Your question was about E naught cell. You said that, yeah, this is fine. For this, it is equal to 0.
yeah, so 0 plus 1.08 is plus
Why
1.0.
अपना मार खा जाते हैं अगर मेरे सामने रहते तो.
So because this one, right? 2 Br negative 2.
अरे भाई, what I have told you earlier, E naught cell के लिए आपको क्या देखना रहता है? E naught oxidation of the species getting oxidized, है ना? यहाँ पे जो आप देखिए, is this getting oxidation? Is this oxidizing? Br2 से Br negative. अबीर, is it
No.
oxidation?
No.
तो साइन चेंज करना होगा ना?
Yes, sir.
वो नहीं याद रखना है आपको.
Okay.
Look at this, whatever they have given. Okay. चलिए. Now this is a very different portion of this chapter about conductivity, है ना? So what is conductivity? Can someone tell me? What is conductivity? Sorry?
L by A. No. The opposite of resistance, right?
Very nice. चाय क्या है सर? कॉफी नहीं है सर, चाय है ना? हाँ? What is conductivity?
Rho.
Rho.
Yeah.
Resistivity क्या है? Do you, Fatima, like, please think now that you are writing an exam for CBSE and answering these things. Will you answer this? Will you write this? Conductivity is rho.
No.
And molar conductivity is molar rho. बताइए, Fatima. What you were saying?
Rho is equal to area by length. Wait.
Listen here, listen. रहने दीजिए आप लोग. Listen very carefully. Suppose there is some iron. There is some iron, okay? And I have taken 5 molar of it. Okay, and I have taken huge amount of that particular iron, and so it will have some conductance, right? There will be some conductance of this particular iron, yes or no? It will conduct electricity. अरे हाँ या तो बोलिए. नहीं, it will not conduct electricity. Yes, Fatima, Abir. आवाज ही नहीं आ रही आप लोगों की तो. Both of you are on mute, by the way. Hello.
Yes, sir.
Where is Fatima?
Here.
Listen. अच्छा, let me tell you one thing. You have a very long wire. ठीक है, ये आप लोगों को ज़्यादा समझ आएगा. This will have a resistance, right? Yes or no?
Yeah.
If I take 1 meter, if I take 2 meter of the same wire, the resistance will be different, correct?
Yes.
है ना? Now, in order to standardize something, ना, अब अगर आपसे पूछे like per meter या per centimeter क्या होगा, तो that is then resistivity, which we have standardized, right? The resistance per meter is resistivity. ऐसे ही कुछ है, right? Yes or no? Tell me.
Yes, sir.
Okay. Similarly, there is conductance and there is conductivity. So in conductance, what happens? Conductance is the like it is the magnitude of how much electricity a particular ion or a particular solution is conducting. So it is extrinsic. That means if you take a greater volume of a particular solution, that means you're going to conduct more electricity. If you're going to take a large volume. And what is conductivity? Conductivity is intrinsic. Now, whenever you have intrinsic quantity, for example, density, if you take mass can be extrinsic. If you take more mass, you will have more like the magnitude or whatever number you're getting in the weight balance, it will be very higher. But if you talk about density, so for density, you will have to divide mass by something that is volume. So similarly in conductance and in conductance. So conductance is directly what you will do, you will measure the electricity that is being conducted. Now conductivity of a solution or an electrolyte, it is what? It is the, again, it is going to be a conductance only, but it is going to be a very specific type of conductance. It is very specific type of conductance. What you will do, you have an electrode like this, and you have another electrode like this. And between these two electrodes, you have solution, right? Between these two electrons, you have solution. And if these electrodes, if these electrodes, they are kept at a distance of 1 meter apart. Okay, they are kept a distance of 1 meter apart, and each of these electrodes, it is of 1 square meter area. Each of these electrodes is of 1 square meter area. Then whatever conductance is between these two electrodes, now this conductance, this specific conductance in which you have a particular distance between electrodes, and the electrodes are also of a particular thickness and area, this conductance is known as conductivity. You have a specific type of cell in which you have specific type of electrodes, and those electrodes are kept the distance between those two electrodes is 1 meter, and both of these electrodes, they are of 1 meter square. Both of these are of 1 meter square area, and then you measure the conductance. And whatever conductance you are going to get, that is going to be the conductivity. That is going to be the conductivity. Is that right? Got it? Yes or no? Tell me. Guys, tell me. Got it?
Yes, sir.
Okay. Now, what is molar conductivity? What is molar conductivity? What will be molar conductivity? It's very easy. Molar conductivity is, just signify this as lambda m, and this is equal to whatever conductivity you have measured. Now, if you see in this particular situation, we just mentioned that there should be this much area between them, and this electrode should be of this much area, the distance will be this much, but we did not signify what will be the concentration. So molar conductivity is conductivity divided by the concentration, molar concentration. Okay? Fine. Yes or no? Tell me.
Yes, sir.
Okay, so this is molar conductivity. Acha. Now, what is conductivity is given by G, right? And conductivity is the opposite of resistivity, and this will be equal to what? Kappa into the area divided by length, right? Yes or no? ये सब चीज नहीं याद है आपको? हाँ guys. नहीं तो पढ़ना पड़ेगा ना आप लोग को, you haven't revised also, है ना? So conductivity is what? Kappa. This is K for kappa into the area divided by the length. Okay. Now both of these are that means area and length. If you are going to measure conductivity, this area is what? 1. This length is also 1. It can be 1 meter, 1 square kilometer, whatever. So whatever conductivity you are going to get, whatever conductance you are going to get, that is going to be conductivity, that is kappa, that is going to be kappa. Now if you write here, this is kappa, the m, this will be equal to what? This will be equal to whatever conductivity you are going to have, and that is divided by the molar concentration. Okay. Achha, next thing is, what is the variation with the concentration? What is going to happen with the concentration that we are having? So let me just erase this part. Now let us talk about the molar conductivity. Okay, let us talk about the molar. Where you got? If you look at the molar conductivity, so this is equal to the conductivity divided by the molarity, है ना? Molar concentration or molarity. If you look at conductivity, which is kappa, divided by molarity, molarity is number of moles divided by volume. So this will be equal to whatever the kappa is into the volume. Right? Yes or no? This is the molar conductivity. Correct? Bataiye. Oh, what happened, guys?
Yeah.
You will have n here. You will also have n here. N common, like I took at this as 1 molar concentration. Right. So lambda m is equal to k on volume upon n. Also, you can see that this is molarity, number of moles here, and lambda m is here. So what is going to happen if I am going to decrease this concentration, then the molar concentration is going to increase. Molar conductivity is going to increase. Yes or no?
Yes, sir.
I will write lambda m is what? It is inversely proportional to the concentration. Got it, guys? Yes or no? Tell me.
Yes, sir.
Yes, sir.
Okay. Now, what about conductivity? So conductivity, it decreases with a decrease in concentration. Okay, it will decrease with a decrease in concentration, because if I have a particular area or a volume in which I am going to calculate the particular conductance, then if there are more ions, if ions are there, then the conductance will be higher. If ions are lower, then the conductance will also be lower. Okay, so conductivity is only dependent on number of ions. It's only dependent on number of ions, and if the ions is going to increase, conductivity is also going to increase. That means if I have concentration which is higher, then the conductivity will be higher. If the concentration is lower, the conductivity will also be lower. Got it? Yes or no?
Yes.
So let us see the different part. Okay. So here you have the conductivity of 0. So what is the time? Class. Okay. So let us do this one question and then we can move. Okay, then we can move. So we have lambda.
Slide.
Huh.
Okay, sir.
Okay. So we have lambda m. Okay, this will be equal to
So
kappa.
we skipped one question. The 3.6. Is that related or something?
Button cells, na?
Button cells. Yeah.
See, first thing is that if you want to write the, can you see that oxidation reaction and reduction reaction? ये दिख रहा है कि नहीं आपको बताइए?
Yes, yes.
उसके बाद आप हाँ, same things will be there ना then?
Yeah. Okay.
Got it? वैसे ही बटन सेल्स वगैरह तो डिलीट हो गया ना? Yes. So batteries and all those are deleted.
It's deleted. So we don't have to do that, right?
हाँ, मत कीजिएगा इसको. Next is अच्छा. So lambda m, which will be equal to kappa, है ना? Divided by the molarity. So molarity is what? Molarity. Okay. Now this will be equal to kappa. What is kappa here? What is kappa given? 0.248. No?
Yeah.
0.0248 Siemens centimeter
Inverse.
inverse, right? Divided by molarity. And what is molarity given? 0.20
0.
moles per liter. Now you have to convert this liter into centimeters. Okay, this liters into centimeter. You got it? Yes or no? Tell me.
What's up? The
You
liter
have
into
you have to convert. This is liter inverse, right? So this will be converted into centimeter cube inverse. Okay, you have to get in terms with this centimeter and liters. Both of these are what? Liter is also, what is the value of liter? Liter is dm cube, na? Liter is dm cube. So liter or centimeter, both of these are a variation of length, correct? If you have length in only one dimension, that means it is centimeter. And if you have liter or volume thing, then the length is cube. Right? So you have to get these two things in their particular units. But for that, what you can do, you can just multiply this whole thing by 1000. 0.0248 Siemens centimeter inverse divided by 0.20 moles per liter. So what you can do, you can multiply this whole equation by 1000. Now please see here, 1000 centimeter cube. Okay. So if you see what is 1000 centimeter cube, it is nothing but it is 1 liter. So I'm multiplying. Okay, so I am, see what I am doing. I'm in the numerator adding a volume of 1000 centimeter cube, and in the denominator also what I am doing, I am adding a volume of 1 liter. So both of these things are same, right? Yes or no? Either I write 1000 centimeter cube or 1 liter. Both of these things are same, because
yeah.
1000 centimeter cube divided by liter, it will be equal to 1 only. Okay. So now what you can do, you can erase this liter and you will have just only one unit of length, that is centimeter cube, and then you can solve this. So this is important point. Please remember this. So when you are defining the molar conductivity, then it is what kappa upon molarity. But when you are solving this, then you have to introduce this 1000 term, which will cancel the liters. Is that fine? Yes or no? Tell me.
So then the mole, it will remain there.
A mole will be in remainder, na?
Mm-hmm.
Because you are calculating molar conductivity. Correct.
Okay.
So conductivity centimeter, Siemens per centimeter, na, per mole. Now this will be molar conductivity. You'll get Siemens centimeter square. Sorry, centimeter square. Okay, Siemens centimeter square per mole. This is the molar conductivity unit. Okay.
Yes, sir.
ठीक है, बस इसका ध्यान रखिएगा 1000 के बारे में. Okay.